in this video we are going to learn about the auto keyword in CPP. Okay, so auto is basically type deduction at compile time. Okay, so important part over here is compile time. Okay, so most of the languages that we use today have some kind of feature that allows them to dynamically decide things in runtime. So like if you're using JS or Python, so that is a different story, and auto works a bit differently because this basically does type deduction at compile time, okay, not at runtime. So this is not a polymorphic behavior, this is a compile time, you can say a resubstitution. Okay, so important part is compile time over here. Okay, so it has a certain rules that the compiler uses to deduce the type. So how exactly does it deduce the type? Okay, so let's get started with the code. Okay, so we'll write a simple code over here first. Auto test2.cpp. okay, simple include, that is iostring, and int main. Okay, so this is a primary structure, so you could create that structure in itself. Okay, so now simply if I write auto x is equals to 10, okay, and I do a cout, sorry, let's do std cout, and value of x, and say x std handle. Okay, so now let's do the compilation. Okay, so here what I will do is I will write std c11, oh sorry, c++11 to enforce the C++11 standard. So post C++11 all standards should be able to compile this code successfully. Okay, so just autotest.o autotest.cpp. okay, so it compiled successfully. So let me tell you that here we assign the value 10. So see, if we hover over this, you might see int 10. Okay, so it deduced that value at the compile time. Okay, so post compilation it was able to deduce that thing and it displayed that thing. Okay, so similarly if I write auto y is equals to 12.5, okay, so even this it should be able to reduce as double. Okay, see, it is able to reduce that thing as double. So this is, you could say, to the primary data types or the primitive data types that we speak of in this the C++11 standard. Okay, prior to this it was not available. Auto keyword was for some kind of other purpose. Okay, like predominantly in C, you could say. In CPP nobody used the auto keyword as such. Okay, so it was for automatic this thing, storage class. So that's a different story, so you have to forget that story. Okay, so now it is used for automatic type deduction. Okay, so this was a simple example of that thing. So now to prove that this feature came only post CPP11, we'll compile it with this thing. See, it will give you, if you compile this with std C++98, then it will give you an error at the auto keyword does not name a type. Okay, so previous to that C++ enforce the type, like you have to compulsorily write over here int or say double. Okay, 1 second. So like now if you run it, so it's not declared in this code. 1 second. Okay, we didn't save that thing, sorry. Yeah, so now it worked because we specifically gave those types over here. So post C++11 this would start working because the auto keyword was introduced. Okay, so now auto keyword is not solely, what you say, limited to the primitive data types. So it is, or you can say it has evolved to much better purpose. So now it is used for complex data types as well as functions. Okay, so we'll see it one by one. Okay, so initially it was only for the complex data type. Okay, so up until like C++11 in itself, like it was 11 to 14 initial days it was up to like this thing only, like primitive data types only you could use auto keyword, but post C++ 14 you will be able to use it on functions or lambdas as well. Okay, so what are functions and what are lambdas and how they will be used, that also we'll see. Okay, so first about the complex types, or you could say the purpose of creating this keyword. So we'll do it the old school way. Okay, so first we'll create a vector. Okay, std vector. Okay, int. Okay, and we see, and let me just add a few elements in this 12, 14, 16, 18. Okay, and I'm still seeing the red lines because I have not imported hash include vector. Okay, so it is very important that you import, or you could say you include that namespace, not exactly import, sorry. Bit confused sometimes between Java and CPP because I use both. Okay, so now let me just, yeah, we'll switch to CPP 11 again. Okay, so just so that we don't mess up some other code. And this here, what we'll have to do is, now if I want to iterate over this thing, okay, so for std vector, okay, so I'm creating a way to iterate this thing. So the classical syntax, what it looks like, that I will show you so that you can appreciate the beauty of auto keyword. Okay, so std vector and int of type int obviously, and its iterator, so like it, and that will point to vector dot begin. Okay, so vector has this methods begin, so this method, so let me just show you the signature of this method. So it should tell vector dot begin. Okay, so see here, you can see here inline std vector int iterator, so this returns an iterator object. Okay, so this also in the C++11 standard, or for the auto keyword, you can deduce this type as well. Okay, so basically the premise, or you could say the reason why this thing was introduced is for this purpose, because sometimes C++ code can get too messy. Okay, so like lot of things you'll have to write. Okay, so it is a mouthful, or you could say has a handful of different types of scope resolution operators, and you mess up with multiple namespaces, so it is very easy to get lost if you are having a very good bigger code base. So this auto keyword helps. Okay, so now moving forward to this thing, so now I have this iterator with me, sorry, it plus plus or plus plus it. Okay, better way. So, okay, I forgot the condition, sorry. It less than, sorry, not equals to vc dot end, and it plus plus it. Okay, so this is how we use an iterator. Okay, so in this iterator you can get or do whatever things you want to do. Okay, so this is for creating an iterator. So this whole big expression can be simply replaced with a, first I will just compile these things just to show you that there are no compilation error. Okay, so now I can replace this whole thing with an auto keyword, and now it works. If you see, the compiler will automatically deduce the type and replace the auto with the relevant type. Okay, so that is the whole purpose of using auto. Okay, so inference of complex types as well as simple data types. Now moving forward to functions. Okay, so this thing was introduced, as I said earlier, in C++14. Okay, so if you are compiling with the C++11 standard, so you can expect some kind of error. Okay, so here if I write auto add, So I'm using very simple functions because those are the kind of functions you use as a beginner. Okay, so just to make you understand the concepts. Okay, so we are not building something really scalable. Okay, so return a plus b, and these are the kind of examples you will get all over the internet just for the explanation part. Okay, and my blabbering comes for free. Yeah, so here if I use this thing in my code, okay, if I write another cout over here for this function, what is the function name? Add, sorry, add 10 comma 12. Okay, let's just compile this thing again. Oh, it has thrown the error, but it is telling you the note as well. Deduce return type only available with C++ 14 or GNU 14. Okay, so yeah, we'll just change this thing, and yeah, now it has compiled successfully. So once again we'll have a run. Okay, so it is giving this value. See, 22, you can see 10 comma 12. Okay, just add like addition. Okay, addition is just add a backslash n over here. Okay, let's add some pendle and recompile this thing. Yeah, so now it has shown the answer. So now this is like for simple functions. So yet another type of functions that we use is called something as lambda functions. Okay, so lambda functions, like you could say, they're anonymous functions. So like what is exactly anonymous function? So like it doesn't have a signature like a typical function. Okay, so I have written here auto sum. Okay, and here I will deduce the parameters also, auto x, auto y. Okay, so essentially you pretty much write what you say, small functions or inline functions whenever you are using this kind of lambdas. Okay, so about lambdas we can discuss in some other video. Like let's not what you say pollute the discussion at this point of time about lambdas, because that's another beast completely. Okay, so addition again is sum. Let's see now if that works. We have yet another set of errors waiting for us. Okay, so yeah, so like I said, if you deduce this thing in such a way, then there might be once again, like we didn't give the parameters. One second. So like, this is what happens when you are not attentive. Okay, oh, yet another error. Sorry, I miss out syntax, I guess. Yeah, after a lot of effort. So yeah, you should learn how to make errors. That is the only way you can learn. Okay, so auto test. Yeah, so this is all about like the auto keyword. So apart from that, there are cases where it is a very bad idea to use auto keyword. Okay, so those cases we'll learn in the future, or in the future, sorry, because as of now I don't think as a introductory stage wherein we are, it is good to introduce those things. Okay, so we'll take it with the what do you say, the light way. Okay, so there are some ambiguities. Okay, so there's a very good book by Scott Mears called Modern Effective C++. Okay, so that has like the initial chapter in itself, like dedicated to the kind of caveats of using the auto keyword. Okay, so if you're eager to move over there, then yeah, you could read about that as well. But yeah, in some upcoming video, once we are at a advanced stage, surely we'll revisit auto keyword, okay, and we'll go into the details. Okay, so hopefully this was an helpful presentation. Okay, thank you.